In some applications, we get input from keyboard to build a binary search tree in the memory, and then we need to store all the data in the binary search tree into a file, so that the next time when we restart the application, we can rebuild the original binary search tree by reading the data from the file. So how to save a binary search tree and then restore it to the original shape? In some applications, we need to save a binary search tree into a file and then restore the binary search tree to a balanced shape, a different binary search tree, but which contains the same set of data. For the first algorithm, we need to restore the binary search tree to its original shape, because the row node data should be the first data we read from a file. That means we need to store row node into the first data in the file too. The only traversal algorithm can do that is pre-order traversal. We can use pre-order traversal on the binary search tree one by one, save into the file, and then we just perform insertion operation of binary search tree on each data to restore the binary search tree into its original shape. How to rebuild the binary search tree to a balanced shape? We know that if the data are sorted, then we know that we should put the medium or middle element into the row node. And then we build the first half of array data for the left subtree, and the next half array of data as right subtree. The tree does not need to be complete. Either left subtree or right subtree can have one more node if necessary. So how to store the data from a binary search tree into a sorted order in the file? In order traversal. That means we need to perform in order traversal on a binary search tree and then save one data by one data into the file. And second step, we just read data one by one, insert into initially empty binary search tree. Of course, if we want to put the middle element into the row node, we need to know the number of nodes. Suppose the number of nodes is odd number, and we compute a full binary search tree. The algorithm will be as follows. The read4 method is going to build a full binary search tree from unsorted value in a file, and this method will receive two parameters. One is input file, second one is number of data. The idea is recursive, so we need to create the row node first, but we cannot get the data until we finish building the left subtree for the row node. So we create the row node with no data and then try to build left subtree by recursively call the method, passing m divided by 2 half number of data, the first half of the items in the file. Suppose we have successfully built the left subtree, the first half of data. Now it's time to read the middle data and put into the row node, which we have already created, and then build second half of the binary search tree, left subtree, or build the right subtree by using second half of the data. The base case is there's no data in the file. We don't need to do anything. Sometimes we cannot build a full binary search tree. It means the number of data is even number. One of the subtrees will have more nodes than other. We could arbitrarily choose the extra node to be on the left subtree or right subtree. In our algorithm, we choose left subtree. So right subtree will have one more node than left subtree. Other algorithm part of algorithm will be same as previous one. Let's make a summary. If we want to save a binary search tree into a file and then restore it into original shape, we need to perform pre-order traversal and save the data one by one into the file. And step 2, try to insert each value into empty binary search tree. If we want to save a binary search tree into a file and then restore it to a balanced shape, we need to perform in-order traversal to save the data in ascending order into the file, and then we perform insertion operation. But this insertion operation is different from the insertion operation of original binary search tree class.